July 24, 1943. Radar station Himbuch, Eisbach, near Hamburg, Germany. Oberreiter Klaus Hartmann gazed at his Würzburg radar screen, his hand arrested on the range adjustment knob, as he looked at something that defied every radar operating principle he had ever learned. The cathode ray tube, normally displaying clear individual aircraft returns, had burst into a solid screen of glowing echoes. Hundreds of them, thousands maybe, each one looking like a valid bomber squadron, blanketing his screen like an epidemic devouring his fine-tuned system. "This can't be happening," he wrote in the station log, his handwriting revealing his bewilderment. "Either all the Allied bombers in the world are hitting Hamburg tonight, or the British have come up with something we never dreamed of. The radar indicates more aircraft than are found in the entire Royal Air Force. My training tells me this ice equipment failure. My instinct tells me we are being witness to a new kind of warfare." Hartmann could hear from his headset the panic spreading through the German air defense network. Fighter controllers were guiding night fighters onto contacts that melted into thin air. Anti-aircraft batteries were blazing away at ghost formations. Master searchlights raked wildly across the sky, their radar guidance systems made obsolete by the blizzard of bogus returns swamping German radar stations from the North Sea to the Ruhr. None of them realized in that instant was that this night would see the start of the most advanced warfare campaign in military history. The deliberate blindfolding of German radar by Allied jamming technology would be more lethal than any bombing raid, more debilitating than any naval blockade. It would compel Germany to transfer 7,000 radar and electronics specialists out of vital weapons programs to a useless search for countermeasures. The Battle of the Invisible War was about to start, and Germany was already behind. The basis of German optimism had been established through 4 years of radar superiority. Since 1939, the Luftwaffe had committed to service what military tacticians regarded as the most advanced air defense network on the globe. The system created by Telefunken and other German electronics company teams the height of radio detection technology. Freya early warning radars could pick up bomber formations at ranges over 120 kilometers. Giant gun-laying radars could follow individual aircraft with accuracy good enough to lead night fighters into visual distance or control anti-aircraft fire with left. The Kammhuber line, which was named for General Joseph Kammhuber, commander of German night fighter forces, included overlapping radar boxes encompassing the approaches to Germany. Each box had ground radar stations, operating in coordination with a single night fighter. With its own airborne Liechtenstein radar, this system had changed night fighting from a desperate search in the dark to a calculated interception where German pilots enjoyed every advantage. Feldwebel Ernst Simon, a radar operator with the 4th Night Fighter Division, had joined the Luftwaffe in 1940, believing in German technology. His Luftwaffe radar school training in Vernoen had enhanced that. "For 3 years, we easily followed British bombers," he wrote to his family in December of 1943, found decades later in Bundesarchiv military records. "We lead our night fighters to them as effectively as shepherds lead dogs to sheep. The British flew by night, thinking that shielded them. We could see them as distinct targets on a shooting range. Our technology was impeccable, or so we thought, until July one night when everything went wrong. The Würzburg radar was German engineering at its best. Working at 53 centimeters wavelength at frequencies of approximately 560 megahertz, it could ascertain range to within 25 meters and angular position to 1/4 of a degree. The parabolic dish, almost 8 meters in diameter, spun smoothly on precision bearings, following targets automatically by a servo system that was at the cutting edge of automation. Production sites all over Germany built hundreds of these sets, each one taking more than 3,000 hours of skilled labor to assemble and adjust. By mid-1943, German radar coverage reached from Norway to the French coast, an electronic net that Allied bomber crews had learned to respect, and bomber command casualties had risen progressively throughout 1942 and early 1943 as the German night fighter force honed its skills. In March 1943, during raids on Berlin, Bomber Command lost 5.2% of aircraft sent out. In June, raids on Ruhr cost 4.7% losses. These were unsustainable losses that jeopardized through whole strategic bombing campaign. At this rate, Air Chief Marshal Arthur Harris reckoned gloomily, "We will exhaust our trained crews before Germany exhausts its cities to defend." The U.S. daylight bombing offensive was similarly plagued. 8th Air Force B-17 Flying Fortresses and B-24 Liberators streamed through drapes of radar-guided flak that destroyed aircraft with mechanical accuracy. German Würzburg radars followed the close bomber formations, sending information to predictor computers that computed where shells would cross with aircraft. During raids deep into Germany, losses were routinely over 10%. Schweinfurt's mission in August 1943 would claim 60 of 376 dispatched bombers, a disastrous 16% loss rate that had almost shattered the back of American strategic bombing doctrine. What neither Thelefeld nor the average German radarman knew was that British and American scientists had been working on a counterstrike of unprecedented complexity. The labs in telecommunications research establishment at Malvern, England, and in the Harvard Radio Research Laboratory in Massachusetts had been working on radar countermeasures since 1942. Their secret work would eventually lead to technologies that would make German radar nearly blind. The break for the British came from an unexpected quarter. Joan Curran, a Welsh physicist in the Radar Countermeasures Unit in Trey, had been testing simple strips of middle foil. Her work proved that aluminum strips cut to half the wavelength of German radar frequency bounce radar pulses with phenomenal effectiveness. Each strip that cost a fraction of a penny to make would bounce back a radar echo like that of a large bomber. Thousands of strips dispersed by aircraft would form a cloud of false returns that would totally saturate radar screens. The idea was beautiful as sample, but its introduction had been postponed for more than a year by a strange strategic deadlock. Independent of the Swedes, German scientists developed the same technology, calling it Duppel after the Berlin suburb in which they had conducted research. Both had the ability to blind the enemy radar, but neither would strike the first blow. Professor Frederick Linderman, Churchill's senior scientific advisor, had strongly opposed introducing what the British called window. "If we employ it," he cautioned in war cabinet sessions, "the Germans will instantly copy and employ it against our own radar defenses in future attacks on Britain." Fighter Command and Anti-Aircraft Command, recalling the Blitz, suppressed the technology for 13 months. By July 1943, however, strategic calculation had turned around. Most Luftwaffe bomber forces had been shipped to the Eastern Front. German air raids on Britain was reduced to sporadic harassment raids. More importantly, British scientific intelligence revealed that Germany had not used any new radar frequencies immune from window jamming. The choice was made. Operation Gomorrah against Hamburg would introduce the equipment that would transform electronic warfare. The production program moved at breakneck speed. British factories, including those affiliated with the Ministry of Aircraft Production, started fabricating window in amounts astonishing military logistics officers. Each pack held 2,200 strips of aluminum foil laminated to paper, about 27 centimeters long and 2 centimeters wide. The strips were cut and packed by hand, at first by workers, mostly women, who had been hired for war work, and later with more mechanization as demand soared. By late July 1943, British industry was churning out more than 200 million strips a week, enough to arm every bomber in action against Germany. The operational deployment was carefully planned. 24 Lancaster bomber crews were briefed specially on July 23 regarding the new equipment they would be using. Flight Lieutenant Harold Martin, a Dam Busters veteran, noted his response in his flight log. "We were instructed to drop bundles of what appeared to be Christmas tinsel down the flight. 1 bundle per minute. Using a stopwatch for the timing." Intelligence officers promised this simple procedure would blend German radar entirely. We all believed they must have gone out of their minds. How were pieces of foil going to beat the German air defense system? We would find out soon enough. The night of July 24, 1943, started as hundreds of earlier bomber missions had started. At bases throughout eastern England, ground crews readied 791 aircraft for the maximum effort against Hamburg. Lancaster, Halifax, Stirling, and Wellington bombers were loaded up with a catastrophic combination of high explosive and The explosive bombs would blast roofs off house and shatter glass. The incendiaries, 350,000 individual devices in all, would then set alight the uncovered wooden buildings. And once started, this would become an unstoppable fire. The unique thing about this raid was the extra cargo placed inside each plane. window bundles and crates stacked close to flare. Chutes sat ready to be jettisoned at 60-mi intervals on approach to Hamburg. Each bomber had enough to generate a nearly continuous display of false radar returns for the final hour of the mission. At radar facilities around northern Germany, the night crew started their shift with no idea that tonight would be like so many others. Oberfreiter Hartmann, at 3G, finished his check of his equipment with all the finesse of a pro. The Würzburg radar call, Sankanon 3, reacted well to calibration. The screen exhibited the usual background clutter of ground returns. Radio chatter with fighter control at Stade was clear. All set for another night of leading fighters to British bombers. The first sign of the raid came about 2,230 hours, when Freya long-range radars picked up formations gathering over eastern England. This was normal British practice. Nothing out of the ordinary. Fighter controllers, initially Fighter Command Headquarters at Metz, started planning the forming raid, estimating probable targets from Theercraft courses. The bomber stream was seen to be coming up for a penetration into the Ruhr industrial area or Hamburg. Night fighter crews at the bases from the Netherlands to Denmark were told to stand ready for scramble orders. Then, at exactly midnight, when the bomber stream crossed the German coast at Cuxhaven, something unusual happened in the whole German radar network. Radar operators monitoring their scopes noticed them suddenly become filled with returns. Not the normal, steady line of individual bombers which could be counted and followed, but a burst of echoes that made it impossible to identify individual targets. At Station 3G, Hartmann observes Belif as his painstakingly measured show was rendered useless. Where previously he had been following 3 bombs, his screen indicated what seemed to be hundreds of planes along a front 30 kilometers deep. The confusion in fighter direction rooms was instant and complete. Controllers who were trying to steer night fighters toward contacts saw their commands rendered senseless within minutes. There are rebombers in every location. One of our controllers at Stade was reporting desperately to divisional headquarters, but we are unable to pinpoint individual locations. The radar is giving solid returns all over the sector. Fighter controller cannot direct fighters to individual targets. Our master searchlight batteries, which used radar to locate bombers in the dark, beat wildly around the sky. Their Würzburg radars indicated the same meaningless clump of returns. If they shine, where the radars, each course indicated targets, but vision detection detected empty sky. The anti-aircraft batteries were confronted with the same paralyzing confusion. Black crews relied totally on radar direction to point their guns at unseen targets in the darkness of the night sky. Their predictor computers required precise range and bearing information to compute firing solutions. Now their Würzburg radars provided them impossible information, indicating bombers at all altitudes, every bearing, every range at the same time. Some batteries shot randomly into the general region where radar indicated. Others stopped firing altogether. Their commanders, realizing that blind shooting wasted ammunition, and gave away their locations to British bombers. In the cockpits of Bf-110 and ROHE-8 night fighters, pilots shared the same confusion. Their airborne Liechtenstein radars, which had worked so well in the past to find bombers in darkness, now reflected the very same confusing mass of returns that afflicted ground stations. Major Heinz-Wolfgang Schnaufer, who was already an ace with 19 confirmed kills, had his radar totally jammed. I could see returns wherever my antenna pointed, he reported in his combat report submitted after the mission. But when I flew towards them, they would disappear or proliferate. It was impossible to identify authentic bomber echoes from whatever was creating this record jamming. I tried visual searching, but bomber stream was to spread out. We flew blind that night. Our advantage lost entirely. The 791 British bombers, on the other hand, continued on towards Hamburg, largely unhindered. The well-trained crews conducting window drops, as per briefing, found themselves in an hallucinatory bombing mission where German defenses appeared near non-existent. Only 12 planes were lost that evening, a loss rate of 1.5% as opposed to the 5% losses that had been the norm on recent missions. Flight Lieutenant Martin documented his surprise. The searchlights waved indiscriminately below us, never focusing on any plane. The flak wasn't predictable and obviously unaimed. No night fighter made a firing pass on our formation. The intelligence visors had been correct after all. Those flat strips of foil had made the entire German air defense system impotent. The bombing itself went with uncharacteristic precision. H-2S ground scanning radar, a novel British technology using centimetric wavelengths, offered the Pathfinder planes crisp photos of Hamburg's coastal areas and internal waterways. Marker flares, seeded by the Pathfinders, burned to perfection over the target points. The waves of bombers that followed deposited their deadly payload with textbook precision. High explosive bombs reduced buildings throughout the Alcatel-Neustadt districts. Incendiaries plunged into the opened buildings and caused a fire. That combined into a conflation which was seen from 200 km Hamburg. Fire department reports subsequently reported 2,300 individual fires initiated that, which overpowered all efforts at control. The night of July 24 to 25 ended for Klaus Hartmann and radar operators throughout northern Germany, with a deep feeling of defeat, combined with terror, at the approach of dawn and the return of British bombers to England. The radar screens slowly cleared of the enigmatic false returns. The Würzburg radars reasserted their normal function, following the departing bombers with their accustomed accuracy, but the blow to German confidence was total. We had been made blind, Hartmann recorded in the station log, by some technology we did not comprehend and could not reply. If the British can repeat this, our whole air defense system is out of date. We had become helpless overnight. The German response to this technological defeat was rapid but in the end useless. At Luftwaffe High Command, General Kamhuber hastily summoned an emergency conference of radar experts and fighter commanders. Everyone's question was how the British had been able to blind German radar so effectively. Initial theories spanned new electronic jammers to some kind of radical breakthrough in radar. The truth was more and yet less complex than one would have thought. The solution arrived with savage rapidity when German troops discovered the Hamburg streets, strewn with millions of skinny aluminum strips. Soldiers, police and firemen combing the ruined city found the shiny foil everywhere. Suspended frond trees, which roofed houses, were stacked in streets and floated in the canals. Dr. Hans Penn, the Reich's plenipotentiary for high-frequency investigation, tested samples brought before him with increasing horror. In hours, he established what every German radar expert had dreaded. The British had introduced Duple, the very same radar countermeasure which German scientists had created, but never employed in case they should be retaliated against. The consequences were self-evident, completely devastating. Germany had no rapid countermeasure because German strategists had taken British radar technology years behind German technology for granted. No one had made a priority of building defenses against Duple since putting it into operation appeared tactically unthinkable. Now the British had called Germany's bluff and exposed the fact that the Emperor was naked. All radar installations in the German air defense system were open to the same simple, inexpensive countermeasure. The mad scramble for started straight away, but were confronted with insuperable problems. General Huber subsequently testified to Allied interrogators. Following the conflict, that window deployment, timing was catastrophically ideal for Britain. If you had implemented this 6 months earlier, he illustrated, German industry would have been in a position to develop and mass-produce radar sets functioning at alternative frequencies, impervious to this specific wavelength of jamming. But by July 1943, German radar manufacturing phallus were committed to current designs. The electronics industry was at breaking point, providing for V-2 rocket production, new radar for night-flying aircraft, and a dozen other vital programs. There was no spare capacity at all to retool for new radar frequencies. The tactical solution was just medieval in its directness. Oberst Theo Hermann, an old bomber pilot, suggested a desperate measure he termed wilder sow or wild boar. Single-seat day fighters would be employed at night, depending solely on visual detection of silhouettes of bombers against search lights and fires on the ground. Fighter pilots would be told to go to general areas where of windows identified the stream of bombers, then would stalk alone with their eyes instead of radar. It was a nasty tactic that was somewhat successful, but at awful cost. Day fighter pilots, not trained for night flying with inadequate instrumentation, lost large numbers to accidents and friendly fire. The strategy was not much more than a last gasp recognition that German technological ascendancy had disavowed. The Americans, observing British success with window, quickly stepped up their own radar countermeasures program. The Harvard Radio Research Laboratory, in close association with British scientists at MA, had been progressing electronic jammers that could actively jam German radar instead of merely producing false echoes. Their most effective production was a system called Carpet, intended specifically to jam the Würzburg gun-laying radars that controlled German anti-aircraft fire. Carpet was a beautifully designed system that was the state-of-the-art in electronic warfare technology. Unlike Window, which was a passive reflection off radar pulses, Carpet was an active jammer that sent out radio frequency noise directly into German radar sets. The AAPT-2 version installed in American heavy bombers was a receiver that picked up German Würzburg radar transmissions and a transmitter that sent back a powerful jamming signal immediately on the same frequency. The impact on German radar operators was devastating. Their screens, rather than displaying clear aircraft returns, were filled with a nonsense blizzard of noise that rendered tracking impossible. Technical Sergeant Trebert Chen, a radar countermeasures officer on board with the 384 bomb group, wrote of Carpet's success in a combat report in December of 1943. We had 2 carpet jammers aboard our B-17, one manned by myself and one by the Bolshevik gunner. While we were over hostile territory, I would sweep the frequencies employed by German gun-laying radar with my own APR for search receiver. When I picked up a Würzburg transmission marked by atypical pulse pattern, I would set one jammer to that frequency and turn it on. The German radar would be immediately filled with noise. From the bomber, we could literally see the results as bursts of flak which had been following us precisely would abruptly scatter wildly, firing at any altitude and bearing. It was most satisfying to observe German gunnery degenerating from accuracy to guesswork. By late 1943, the combination of Window and Carpet had lowered German anti-aircraft effectiveness by an estimated 75%. 8th, Air Force statistical studies indicated spectacular reductions in bomber losses to flak on missions in which radar countermeasures were used. Bomb groups employing both Window and Carpet barrage jamming reported flak loss falling off from 2.5% to 0.4%, 4%, with substantial battle damage falling from 5.5% to 0.8%. These figures represented hundreds of bombers and thousands of aircrew lives saved by electronic warfare and not armor or firepower. The German reply became more desperate as Allied jamming became more advanced. At research labs around Germany, scientists toiled in an effort to create countermeasures to the countermeasures. The Laus program, so-called because of the German term for louse, tried to take advantage of the fact that window strips descended relatively slowly through the air while planes had high speeds. This velocity difference would in theory enable radar systems to discriminate on the slow-moving chaff, returns and only sense fast-moving aircraft. Development of frequency-agile radars was a priority. If German radar was able to change its operating frequencies quickly, Allied jammers would find it hard to track and jam each new drone frequency. The FUG 220 Liechtenstein SN2 airborne radar that was introduced late in 1943 operated in the 90 MHz band, well below the frequency range on which Window had been chopped to. JM Telephone FUG 220 employed a new antenna arrangement, known as Herskavy or stag's antlers, involving 8 large dipole elements extending forward from the nose of the aircraft. The lower frequency permitted this radar to penetrate window clouds which blinded previous systems completely. During several months, Germanite fighters regained some effectiveness, employing the SN2 radar. Major Heinz-Wolfgang Schnaufer, who would go on to be the highest-scoring night fighter ace with 121 confirmed victories, attributed the new radar with restoring his killing efficiency. The SN2 enabled us to discriminate real bomber returns from the chaff that had blinded our earlier radars. He wrote in a technical report to Night Fighter Command in February 1944, I was again able to follow bombers through the jamming and lineup for the kill shot. But this was a temporary advantage. Allied intelligence was relentlessly complete. The technologies finally tipped in favor of the Allies in May 1943, when 3 German radar operators, Oberleutnant Herbert Schmidt and his crew defected to Scotland in a Do-88 night fight with early Leinstein BC radar. The aircraft, which stayed largely intact after coming down at RAFDICE in Aberdeen, gave British scientists full technical intelligence of German airborne radar. Within a few weeks, new countermeasures had been devised. TRE's Surratt system was a passive receiver which picked up Liechtenstein radar transmissions and gave British Mosquito night fighters bearing information to home in on German aircraft. The hunter had become the hunted. German night fighters, their radar signals giving away their positions, were being hunted by British fighters employing German technology against them. The intelligence coup was replicated in even more catastrophic fashion. In July 1944, AJ-88G, one night fighter from 7 Staffhoff-Nack, Gashwata, 2 armed with the allegedly secure FUGG-220SN-2 radar and the FUG-G227 Fesberg detector, accidentally landed at RAF Woodbridge in Suffolk, after the crew got the British navigation beacons mixed up with the German ones. The aircraft was taken over intact with all its electronic warfare gear in excellent working order. British scientists comprehended every aspect of the new German radar technology at once. New jamming systems were underway within days, custom-built to beat the SN2 frequency range, antenna patterns, pulse characteristics. The whole lot were now familiar to Allied countermeasures experts. The Piper jammer, developed quickly by TR following the Woodbridge incident, was intended to blind the SN to radar, fixed in RAF fortresses and liberators of 100 group. Specialist electronic warfare aircraft, Piper produced a cone of jamming behind the aircraft in which subsequent bomber formations could move with relative freedom from night fighter interception. The impact on German night fighter effectiveness was dramatic and immediate. Bomber command losses, which had reached alarming heights during the Battle of Berlin during winter 1943. 244 fell steeply after Pipperack. General, in mid-19, Ernst Zimmermann, the radar operator who had started the war assured of German technological edge, wrote with bitter resignation in November 1944, "Are losing the electronic war comprehensively. Every radar system we deploy is jammed within weeks. Every frequency we use is detected and repulsed. British planes that we cannot detect on radar stalk us with our own transmissions as guiding lights. American bombers who used to fly through deadly flak now fly through our defenses at will because our gun-laying radars are jammed into uselessness. We have been brought down to gunfighting with our eyes like aviators in the last war, while the enemy fights in an invisible electromagnetic spectrum where they have complete control." The total impact of Allied electronic warfare was overwhelming. Germany had been compelled by 1944 to redirect immense resources to a losing struggle in the war of radar. 7,000 electronics experts, engineers, and scientists desperately needed for other weapons programs were transferred to research in radar countermeasures. This was almost 90% of Germanish Agrexi radio. Specialists all frantically seeking answers to Allied jamming that appeared to change quicker than German countermeasures could be put in place. Radar production plants that might have been making radar Feuerbot or tank fire control systems were constantly being retooled to make new radar frequencies and configurations. Each one out of date almost before it went into service. The strategic implications reached far farther than short-term tactical performance. German aircraft and anti-aircraft gun manufacturing doubled in order to make up for impaired radar. In August 1943, 45% of all German home defense fighter aircraft were allocated instead of seeing action with ground forces on the eastern and western fronts. German heavy anti-aircraft guns rose by more than 25%, each battery needing personnel, ammunition, and maintenance that took resources away from frontline units. German industrial war production redirected to home defense was an inadvertent but overwhelmingly significant introduction of Allied electronic warfare. Fronts of combat were severely disadvantaged by shortages of air support as resources were devoted to repelling bomber streams that German radar could no longer efficiently locate or attack. Manpower requirements became just as crippling. German anti-aircraft units ultimately accounted for 25% of all ammunition manufactured and needed, levels of manning that drew 1 million men from other military service. They were men who might have been battling on the Eastern Front or manning Normandy beaches, rather standing alongside a jamming hampered radar-controlled guns whose physical potential was greater than what they were actually able to do. The psychological effect on German radar men and fighter pilots was no less crippling. Klaus Hartmann, whose July 24, 1943 watch had seen the initial window deployment, maintained a personnel journal found at the end of the war. His logs followed a progression from confidence to confusion to despair. In August 1943, he had written, "We adapt our procedures constantly, but the British adapt faster." In December 1943, it has become evident that we are outnumbered, not merely in numbers, but in quality of electronic equipment. By March 1944, I no longer think that we can win the radar war. The Allies know our systems through and through, and counter everything we bring into play. We are blind fighting an enemy who can see. The ultimate disintegration of German air defenses in 1944 occurred as Allied air dominance was absolute. D-Day operations during June witnessed the mass advanced electronic warfare, deception, operation of the conflict, Operation Glimmer, and Operation taxably employed radar reflectors attached to balloons and dedicated aircraft releasing window in carefully laid out patterns produced the radar signature of enormous invasion fleets closing in on the deflecting German attention away from the true Normandy landing sites. German radar operators, their equipment already compromised by months of jamming, were unable to discriminate true threats from electronic ghosts. The invasion was successful in part because German commanders could no longer rely on their radar to inform them where the true attack was taking place. At the end of the war, American heavy bombers carried two or more electronic countermeasures systems. The AAP to carpet jammer was standard equipment with over 14,000 units manufactured during the war, more than all other Allied electronic warfare equipment produced combined. This dramatic figure testifies both to American industrial capability and to the critical priority assigned to jamming German radar. RAF bombers loaded comparable amounts of countermeasures gear with number .100 group. RAF operating specialized electronic warfare aircraft that escorted bomber streams producing jammed cones of protection in which attacking bombers would be able to function at dramatically lower losses. The technological heritage carried much further than the direct military impact. Electronic warfare hardly met the notion of radar countermeasures and countermeasurists trends that would dominate military technology development for decades. The swift development of jamming and jamming tactics showed that technological advantage was temporary, that electronic warfare was an endless race between detection and deception, visibility and invisibility. Post-war interrogations of German radars revealed the full extent of their defeat. Dr. Hans Pendel, testifying to Allied intelligence officers in June 1945, provided a comprehensive assessment. The deployment of Window in July 1943 was the turning point from which we never recovered. He stated, "Every later development was reactive, playing catch-up to Allied innovation instead of pursuing our own." By 1944, we were 6 months behind Allied countermeasures technology. By 1945, the difference had increased to a year or more. We lost the electronic war, not due to less able German scientists, but due to Allied production capability and intelligence collection creating an unbridgeable advantage. We were engaged in a war of innovation we could not prevail. Henadel Yusuf, Kamuba, whose combined air defense system had been the Luftwaffe's pride, had similarly dismal testimony to give. The Kamuba line, which in 1941 and 1942 had proven so successful, was rendered useless in one night when Window was introduced. He informed his questioners, "We made our adaptations, but each one was responded to by Allied jamming in weeks' time." The coup de grace came when our own planes were intercepted and destroyed with detectors homing in on our radar signals. We were beacons leading enemy fighters to us. The psychological impact on night fighter crews was catastrophic. They realized that every time they used their radar to locate a bomber, they were exposing themselves to British fighters with Surrett detectors. The hunters had become the hunted. The strategic-bombing campaign succeeded in the end, not only from the tonnage of bombs falling, but from the fact that electronic warfare blind German defenses. Statistical analysis done post-war showed that bomber losses decreased precipitously once thorough jamming was employed. In 1943, prior to mass employment of window and electronic jammers, bomber command loss rates averaged 4.5% per mission. As of late 1944, with complete electronic warfare support, loss rates had dipped to 1.5%, despite German air defenses actually growing in sheer numbers. American 8th Air Force saw similar gains with loss rates to flak decreasing by 75%. After carpet jammers became routine equipment, the human toll spared by electronic warfare was enormous. Conservative estimates put radar countermeasures saving more than 450 heavy bombers in the 8th Air Force alone, an equivalent of some 4,500 aircrew lives. Bomber command estimates indicated equivalent effects with around 800 aircraft saved by lower loss rates. Due to the effect of window and jamming systems, they were not theoretical bears, but living men who were reunited with their families after the war because British and American scientists had outsmarted German radar science. The intangible conflict waged in the electromagnetic spectrum was as critical as any campaign waged with bombs and bullets. Klaus Hartmann, the German radar operator who had seen the initial window deployment, lived through the war and immigrated to the United States in 1952. Eventually becoming an electronics engineer in California. In a 1978 interview for a project on military history, he looked back on that July night 35 years before. When I saw my radar screen fill with impossible air returns, I knew at once that everything had changed. Though I did not know what I was seeing, the British had done something we believed impossible. They had rendered their bombers invisible, not through stealth or trickery, but by overwhelming our capacity to see signal from noise. Looking back, that was the evening Germany lost the air war. We did not would soon come to know it. But the result was decided at that time, when our technological superiority vaporized like morning dew in the sun. The tale of German radar operators facing Allied jamming technology is one of the most sensational technological turns on the battlefield in history. It showed that wars are not only fought with guns and men, but with knowledge and ingenuity. The side of that was capable of outthinking and outproducing its adversary in the unseen. Electromagnetic spectrum enjoyed a winning edge that no valor or resolve could counter. German radar men, as experienced and committed as they were fighting a war they could not win because Allied scientists and engineers had overcome difficulties German planners could never have conceived. The lesson was more general than technology. Electronic warfare set the principle that contemporary war is waged on numerous levels at once. Domination of the electromagnetic spectrum was as important as domination of air, earth, or sea. The countries that understood this fact and spent accordingly created advantages determined combat results decisively. Germany, despite its technological advent in 1943, never truly overcame the shock of July 20, when thousands off-plane aluminum strips made elaborate radar systems obsolete. The invisible war had been fought and lost before most German commanders even understood a new form of warfare had begun. That remains the most devastating defeat of all. To lose a battle you never knew was being fought until after it was already